Hello and welcome to the wiki. Hang on, that's not right.
That's not
Well,
right.
that's not. Welcome to Sparks and Quarks. That's the one. And this is a new podcast, ostensibly based around physics and engineering, but like a large tech conglomerate, will hopefully grow to encompass more than what we started with. We'll see what happens. This is an organic process, isn't it? So yes, hello. I'm Dan, and I'm joined today by Adam, my co-host. Hello, Adam.
Hello, Dan. How's it going?
Oh, it's going very well, thanks. This is exciting, isn't it?
It is. It's really exciting. Coming from a world where we're just looking on other podcasts. It's pretty exciting.
Not to name any in particular.
Yeah, not to name any in particular. Wikicast, man.
Yeah. So the plan for today is we've both got a topic based around physics or engineering that we're going to be discussing, but we figured Adam and I, we've chatted a bit online, but we don't really know each other, so we're going to see if we can get to know each other, really. So, Adam, do you want to go first?
Yeah, so I'll ask you a couple of questions first.
Let's do it.
First of all, where are you from?
Where am I from? Originally, I'm from Hampshire. Well, I suppose technically originally from London. Moved to Hampshire. Lived there for 18 years of my life. Then moved to Bath. Studied engineering at university for 5 years. And I'm now based down in sunny Cornwall.
Wow.
It's a good place, yeah.
Very nice. Yeah. So, what do you do in your spare time?
Oh, in my spare time, I had to say, I'm a big PC gamer. I do enjoy getting home at the end of the day and just unwinding, logging in, and then remembering that I'm absolutely terrible at any kind of gaming I do, and logging off at the end of the evening going, well, that was a waste of time. Why the hell did I do that? But apart from that, it's great. I play a bit of Overwatch, play a bit of Civ 5 sometimes, which is a great game.
I do love a bit of Civ 5. Civ 5 is one of my favourites. I never really got into it that much, but
it's great.
I was a bit late to the party.
Yeah, it's a bit difficult when you go up against Gandhi and you hit the nuclear age. He's quite feisty. Quite feisty.
Not really expected, but
No, exactly.
Okay.
But apart from that, I'm currently in the process of building a remote control plane. I'm going to build myself a quadcopter as well.
Wow.
It's just off the back of my dissertation, really. It's kind of sparked an interest in autonomous flight.
Yeah.
So we'll see where that goes.
Yeah, well, we'll have to talk about your dissertation at some point.
Absolutely.
Yeah, hopefully up as well. Yeah, you would hope. So yeah, bit different question, but what's your favourite film?
Favourite film? I reckon probably Back to the Future. Probably, I think it's got to be original Back to the Future. It's just such a nice concept. Like time travel, time travel as a concept has been around for so long. I'm sure it was done before, the Time Traveller by, I want to say Orson Welles, but that's not right, is it?
I don't know.
This is severely showing my lack of sort of classic literature, and anyone who knows anything about English is going to be screaming at me now.
Honestly, I think anyone who knows English is definitely going to be screaming at me because I'm awful with anything to do with the English language. So,
but yeah, it's a great film about it's got the balance of comedy is right. Yes, okay, the physics isn't necessarily completely accurate, but it's an entertaining film. And
you get into the physics of time travel and then everything just gets a bit messy and you'll just have professors screaming at you saying, don't even go there.
Well, exactly. You got all the bootstrap paradox starts coming in and all this chat, yeah. But take it as an entertaining film with a nice sort of sciencey premise, and it's a great evening to just sit down and binge through that.
Okay, yeah. I haven't watched it in an awful long time, so I'm going to have to watch it again at some point.
Yeah, I'd advise it.
But yeah. Okay, I've got a last question for you. This one's a bit of a different question.
Okay. Yeah,
so, what would be the hat to end all hats? What could you wear on your head that would make people stop what they are doing and stare in awe and amazement?
Right, okay. Oh, crikey. See, as time has gone on, people have started wearing weirder and weirder things on their head. And I think we're almost getting to the point now where you can put anything on your head, call it art, and as soon as people know, oh yeah, that's art, they won't they won't give it a second glance. They'll be like, oh yeah, that's just it's a fashion thing. So it's going to be something so out there that people go, what are you doing? So I think, frankly, it's got to be another human.
Another human.
Yeah, just
Wow.
another human just sat on your head. I mean, you've got to have very strong neck muscles, or you find a baby, just find a baby, stick it on your head, wear it as a hat. But
Find a baby.
look, there's probably some ethical concerns there, but
Yeah, maybe.
if you can get around them, I think a baby hat would certainly be the people would certainly stop and stare if you were wearing a live human baby on your head.
I think they would. So there we
Yeah.
go.
So
A baby hat.
just to give you a slight insight into how my crazed mind works.
Yeah, I mean, I was thinking straight up fedora because fedoras are memes, you know.
Oh, I should have gone. Oh, why did I not go the meme
But
answer? Oh, what have I done? Oh, I'm
memes are
sorry.
life.
Memes are life.
Memes
It's
are
true.
life. Actually, memes are love. Memes are life.
Oh no, don't know. Audience, if you get that reference, I'm so sorry. I'm so sorry that's been put into your head. We are going to move swiftly on. We're going to switch this round. And Adam, I'm going to be asking.
Yes.
I'm going to be asking, like an interview. I'm going to be asking the questions now.
Okay.
You may recognise some of these questions. So, Adam, where are you from?
Oh, okay. This is like deja vu.
It is, isn't it?
I'm from North Devon, sunny North
Ah.
Devon, rain central of the world.
Is it really that wet?
It's pretty wet. I think it's one of the wettest places in the United Kingdom, actually.
There's
yeah,
unsavory
cheeky,
jokes to make here. We're not going to
Yeah.
make them. We're not this kind of podcast. Anyway, carry on.
Yeah, so there's lots of lovely, lovely beaches up here, such as Woolacombe and Saunton, to name a few.
Very nice.
If any of you sort of come down to North Devon for your holidays, as an awful lot of people do in the UK, you will probably have heard of those. There's also Ilfracombe. Personally, I live just outside of Barnstaple.
Oh, I know. Yeah.
So yeah, it's a nice enough place. I mean, I'm up in Bristol when I'm at university, as I am a physics undergrad at the University of Bristol.
Ah, okay. When did you start that? When did you start at university?
I've just finished my first year actually. So
oh, congratulations!
Anyone who has problems with my physics in anything I say, I am getting sources online. Okay, please do not rip into me. Just give a bit of nice criticism.
Oh, see.
Or we may even come back to it in the next episode. Say, what did we get wrong in the last one? Because that happens a lot in physics.
That's really annoying. So you have that justification of, oh, it's your first year. I did 5 years at university. I'm currently working as a robotics engineer. So if I get something wrong, that's it. Like, I'm going to be ripped to shreds.
Yeah, especially if it's about robotics.
Oh no, I'm going to avoid all topics about robotics because
you better because
safer,
your boss might be listening, and then
I mean, he's a great guy, but I'd be surprised. Like,
Yeah.
I really would.
Yeah.
Anyway, what? Again, you might recognise this question. What do you do in your spare time? What do you do to unwind?
Actually, you know what? I'm pretty much the same as you.
Oh, really?
I'm a bit of a PC gamer myself. Yeah. Play a bit of League of Legends.
Okay.
Here and there. I'm not very good at it. I'm almost exactly the same as you in that I play games with my friends. I'm the worst out of us all, and
Whoa, hang on. I never said I was the worst out of my group of friends. Don't drag me down just because you have your own inadequacies.
I'm sorry. I just mean, you know what you said.
I do know what I said, and the record will back me up.
Although Mind Night, if anyone plays Mind Night or knows what it is, I'm pretty good at Mind Night.
I have seen references to Mind Night online. I still don't know what it is, or how to play it, or anything really. I know it's two words that have been put together.
Yeah, I mean, we're both part of the Wikicast Discord, so we do play it as on the Wikicast Discord as a group of friends. So we'll have to get you involved at some point, Danby.
Yeah, okay. I like the sound of that. We'll see what happens.
Yeah.
Cool. Okay. So, same question. What's your favourite film?
My favourite film. It's absolute classic.
Yeah.
Lego Batman.
Oh, you're going to hate me when I say this.
What?
Still haven't seen it.
Oh, no.
I know.
I watched it for the second time on the plane back from the Caribbean a couple of weeks ago.
Whoa. You were in the Caribbean?
I was in the Caribbean.
Jamaica? Wait, how that joke doesn't work?
It's the Dominican Republic.
Oh, sorry, it's a terrible joke.
Beautiful.
Oh, you're going to have to send over some photos. That does sound good.
Yeah, I will. But yeah, Lego Batman. It's absolutely hilarious. It's honestly one of the greatest creations, I think, of all time.
Tell you what, if we do a second one of these, which I really hope we do, by the next next time we record, I will have watched Lego Batman, and that is a
Okay.
Dan Hanby promise.
Okay.
And when I promise to watch something to a co-host of a podcast, I will normally follow through with that promise, naming no other hosts of other podcasts. Moving swiftly on. Final question. Adam,
What you got?
bit of a, I suppose, a philosophical question for you here.
Okay.
It combines elements of, well, a lot of things. It's quite simply, is a hot dog a sandwich?
Is a hot dog. Define sandwich.
Hang on. Why do I have to be the one to define sandwich?
Oh, because, you're the one asking the question.
Yeah, but
I
you're
just
the
want to make
one
sure
considering
that
the
I'm
answer.
correct in all the context,
But this is the thing. This is philosophy. This isn't science. We don't have all of the variables set at the start of it.
Philosophy.
Yeah.
Okay, is a hot dog a sandwich? I'm gonna have to say no.
No. Okay. What's your justification behind that?
It's a barbecue thing. It's not your traditional. Oh, okay, I'm gonna get some mayo and whatever you want to put in your sandwich. Some lettuce.
Literally just mayo. I got two slices of bread, bit of mayo. Oh, what an evening! What an evening! Partying hard there.
Yep. No. I don't think it is a sandwich. It's just not. I can't think of the justification, but in my head, it's just not.
No, okay. Well, it's funny because I was considering this, and I think I'm with you, but I think the justification for me is sandwiches are cold.
Yeah, I was thinking that as well.
Because if you have because paninis are sandwiches. Well, paninis are built the same way as sandwiches, but are then heated up.
Yeah.
But they are their own separate subgenre of food. But if a panini then cools down, you don't say, "Oh, that's now a sandwich." It is a cold panini. So, if a hot dog were to cool down, it wouldn't then become a sandwich. It is a cold hot dog. Still delicious,
I agree.
but not a sandwich. So I think that's where you draw the line. Is it designed to be eaten warm?
Yeah, and I think in which case, if it is, it's not. Although that could sort of bring in troubles when you sort of think of a fish finger sandwich, for example, because that is a sandwich.
I think my brain just snapped because you've just found the exception.
Yeah.
Damn it. Oh, I mean, we're going to have to set up some kind of email address or way of sending in, because I'm sure these are deep philosophical questions. I'm sure people will have a great amount of thought on these, and we're going to have emails and communications flooding in. So we'll have to see if we can set up some kind of contact address by the end of this.
For sure.
Yeah.
If we do, it'll be in the show notes.
Absolutely. Or in the outro. We haven't decided yet.
Yeah.
It's a learning process. It's fine. We probably ought to move on to the first topic of conversation after that brief, weird interlude.
Yes.
So, I think I'm taking the first one, aren't I?
You are indeed, yes.
Excellent. So, I was looking into things, and I was thinking, what would be a good topic? Because I was looking at basing mine around engineering, and what is the kind of... When you talk about engineering, I try and do a lot of STEM work with children, kind of encouraging them to take up science, technology, engineering, maths.
Okay.
And
cool.
Something that really engages them is, of course, rockets, because they're such a visually spectacular sight, and the concept of sending something out of Earth into space is just so cool that it really grabs them. So I thought I'd talk about rockets.
Okay.
And in particular, a company called Rocket Lab. Have you come across them before?
I haven't come across Rocket Lab
before. So I didn't know about them until a few days ago, but they are they're an American aerospace manufacturer, so private company, much like SpaceX. But unlike SpaceX, they don't launch from America. They launch from New Zealand. New Zealand, that kind of bulging hub of, aeronautical activity.
Yeah. Yeah, so I haven't heard of that before. I'm not gonna lie.
Yeah, it's really interesting. So what they've done is they've actually got their own custom-built commercial spaceport. They've built on, I think it's the Mahia Peninsula. Someone will probably correct me on that, which is based on New Zealand's North Island.
Okay.
And so as opposed to other sites, so like NASA, Cape Canaveral, that was obviously that is a NASA site, but is now also used by SpaceX and by, I forget the conglomeration, the aerospace
Is this
conglomeration.
the one owned by the Amazon CEO?
No, that's Blue Origin is a rocket, but I can't remember the name of their program. No, I'm talking about there's Boeing and I want to say like Lockheed Martin or something.
Lockheed Martin, yeah. Lockheed Martin.
They're kind of the besides SpaceX, they're kind of like the other big rocket company, do a lot of launches.
There's also Thales as well. Have you heard of
Thales? Yes, Thales do a lot. I want to say they're called like Advanced Launch Systems or something, but that's not right.
Yeah, I'm not entirely sure.
I'll see if I can dig it out and put it in the show notes later, because in case we want to read up on it. Anyway, we've got our topic. I'm talking about Rocket Lab. So basically, the company was set up in 2000, and he's lost the notes already, 2006. And their purpose is to develop lightweight, cost-effective launch systems for CubeSats.
Right.
So have you come across CubeSats before?
I've heard the name. Not entirely sure what they are.
So a CubeSat is, as the name might suggest, a satellite that is a cube. But the point being, they're very small. Each CubeSat is 10 centimeters by 10 centimeters by 10 centimeters.
Oh, okay.
They are very small. You can bolt multiple CubeSats together to make a larger, module, but obviously that then costs more to take off. But they're kind of becoming almost a standardized design. But you can contact various space launch companies and say, I have a CubeSat I would like to put into orbit. And they, it weighs 6 kilos, and they will say, okay, it will cost you this much. And they want to do that really quickly because they know how much it weighs, they know how big it is, they know when they'll be able to launch it, they know when they can fit it in. It's a really nice way of getting various sort of either research projects or academic projects or amateur radio, Earth observation. They're used for a lot of different things.
Yeah, you know what? I never ever knew that you were able to just contact a company and say, here, I've got this.
Yeah, I mean,
send it to space for me.
Okay, I mean, they're not. There's not masses of companies that do that, but that is a possibility. And universities sometimes will build CubeSats and arrange for them to be launched.
Yeah.
But Rocket Lab, this company, they are set up and dedicated to purely launching CubeSats at the moment. So they're designed to launch payloads of 150 kilos. So depending on your weight of CubeSats, that could be either one massive one or multiple small ones, to a 500 kilometer high sun-synchronous orbit. Now, how much sort of space physics have you covered?
Okay, so I've done a couple modules on astro units this year, and obviously basic mechanics around gravitation and all that, and circular motion. I do kind of know, so.
Okay, so you understand the concept of a sun-synchronous or heliosynchronous orbit?
I think so, yeah.
Yeah, so I have to say, I am not that au fait on space physics. So I am also, as we speak, I am frantically Googling to try and make it sound like I'm more intelligent than I am. So looking at it, it's a near polar orbit, so going over the poles, in which a satellite passes over any given point of the planet's surface at the local mean solar time. Oh yes, I'm having a look at it now. Okay, so yeah, for example, a satellite in a sun-synchronous orbit might ascend across the equator 12 times a day, each time at approximately 3 o'clock mean local time.
Okay.
Yeah, okay, that makes sense. So yes, this company's set up to launch satellites into sun-synchronous orbit. So you can, as I said, you can use those for all kinds of things. The reason I wanted to talk about them, the company in particular, is because obviously they're a relatively new company. Everyone knows about SpaceX. Well, I hope everyone knows about SpaceX. So
everyone should know about
SpaceX. Everyone should know about SpaceX. I mean, if you're not watching their live stream of their launches, then my gosh, what have you been doing? But their Rocket Lab have their main rocket, which is called the Electron.
Okay.
And the Electron, yeah, absolutely. It's a two-stage design. So for those who don't know rocket physics that well, that means that you've got your kind of main launch sequence, your main launch sort of booster. Well, it's not a booster, but this is where my lack of knowledge of rocket physics comes into its own.
Yeah.
But so you take off with an engine or a cluster of engines, and then you'll often drop that series of engines, and then you'll have a second engine or third engine, and that is your second stage. So it's rather than use up all of your fuel in one engine, you kind of will split it into multiple stages, and that is technically more efficient. And I can't remember why it's more efficient, but it is.
I think it can also be to do with changing from a solid fuel to a liquid fuel or a gas fuel.
That's certainly one part of it, I think. Yeah.
Yeah, because I think once you get up to a certain altitude, other types of fuel become more efficient.
That makes sense. Yeah.
I think it's to do with that, but don't quote me. Don't at me.
Don't at me. Well, it's a good thing that, not too many people are going to listen to this and start pinging you messages on Twitter and, Discord and all that.
Yeah, probably got that completely wrong, but who knows?
We're gonna find out we have an actual rocket physicist listening to this, and he or she are just going to be tearing their hair out at all of the inaccuracies we're quoting as, oh yeah, this is how it works, and they're going, no, you're giving people wrong information.
You're so stupid.
So the point of this Electron, which I really like, is the engine design. Now, there are two things about the engine design that I really, really like.
Okay.
The first is that it's the first ever electric pump-fed engine.
Okay.
So for those of you who don't know as much about rocket engines typically are powered by two components. They're powered by the propellant and then the oxidizer. So the propellant is obviously what burns to give the thrust, and the oxidizer is mixed in with the propellant to make sure that it has the oxygen required to burn, because obviously you need a good amount of oxygen to burn. And there are different ways of mixing those two together, because you can't mix them together beforehand and then burn them, because a lot of them are, I've already forgotten the word.
Volatile?
Yeah, some of them are volatile. That's not the word I was looking for. If they come into contact with each other, they can just catch fire.
Yeah, I mean, it's also to do with, like, saving space.
Yes, yeah.
Because you use different tanks, and the pressure changes once you oxidize something. If it's at a higher pressure, then stuff could happen that you don't want to happen.
Yeah, exactly. Rockets are dangerous, kids.
Yeah, they are.
So there are multiple different ways of. So the point is you can't pre-mix them, so you have to mix them as you're sort of burning them and sending them out the bottom of your rocket. There's multiple different ways of doing that. So one of them is called stage combustion, which is where you have multiple combustion chambers. So you'll burn a little bit, and then you'll pass that through, and then you'll burn some more, and pass that through, and burn some more, and you end up with a higher fuel efficiency. But because you've got the multiple chambers, you're trying to control all that energy. It's much greater engineering complexity, which often requires, obviously, is a lot more dangerous, but also requires more weight to make sure it's all safe. And
of course, a lot more money and a lot more time.
Exactly. And goodness knows these things are expensive. So anything you can do to slightly cheapen them is always very much appreciated by the project managers.
Yes.
Another option is a gas generator. So that's where you just burn some of the propellant without use of the oxidizer, and you use the hot gas that's produced by that to drive the engine pumps, which then drive the propellant and the oxidizer into the main combustion chamber for burning. So you're powering the pumps off of a little bit of propellant. So nice, simple design, but because you're using some of your fuel to drive the pumps, it's obviously then less fuel efficient. So
it's essentially what they're using at the minute is two mechanical systems rather than an electrical system.
Yeah, exactly. I mean, it does give you a less expensive and nicer engine to use, but yeah, it is fuel efficient. What's used, I don't want to say a lot because again, I don't know. It's a pressure-fed engine, so you have liquid helium that is kind of. It's in tanks and is then forced into the top of the tanks for the propellant and the oxidizer. And so the pressure from above kind of pushes the two components down into the combustion chamber.
Right. Okay.
So it's like it's a pressure fed system. It's using pressure to force the propellants into the engines. Again, nice and simple because it's a great concept. It's like just a plunger, an air plunger from above. But you're using liquid helium, you've got heavy cryogenic equipment, you've got to make sure it's all contained, you've got valves, all kinds of things that can go wrong. It's a nice system, but heavy and complicated.
Yeah, okay.
And then the final one, as we talked about, is solid fuel. Really nice concept.
Yeah.
Like, I was looking into this. Most people think, oh yeah, solid fuel, you light them, away they go. There's no control. You can, the more advanced ones, you can actually control. You can control their thrust. You can actually turn them off and then relight them again.
Oh, really?
Yeah, absolutely. Or you can have pulsed solid fuel rockets. So you can have like the first meter of the solid fuel. You can have that burn up, and then there can be a next section which you have to light from a signal or whenever you want. So you can have it. So they are somewhat controllable, but they're good to use on as like the solid rocket boosters on the space shuttle. They're good as like launch to help with launch, but you don't want to be using them for your main stage engine.
No, or just little navigation boosters. They're not useful in that sense.
Yeah, exactly. So that's why I really like the Electron. It's this brand new electric pump design, which you do lose a bit of sort of overall efficiency because you've got the weight of the batteries and of the pump.
Yes, yeah, of course.
But but you have lower development and manufacturing costs because mechanically it's a lot simpler. Because it's like, well, how are we going to get these two liquids into this thing? Oh, we're going to pump them.
Yeah. I mean,
that's it. You don't have turbo machinery that can go wrong. You can control the speed of the pump, so you can control burn rate. It's a really nice system. So I'll be interested to see if they're the only ones who go down this route, or whether SpaceX or Boeing or Lockheed Martin or whoever will also start looking into electric pump systems.
I mean, go on, sorry.
No. I was going to say I'll be surprised if SpaceX weren't considering it, given how closely related they are to Tesla and their battery sort of side of things.
Gigafactory and stuff.
Yeah, exactly.
Yeah, so I was thinking sort of in terms of the physics side of things, like what you were saying about the batteries being heavy and stuff like that. These other companies will probably start to look into it more once our batteries develop a bit more. Because, I mean, battery technology just hasn't developed at all since it came about, really.
Exactly. It's really interesting when if you look at the developments happening in every other sector and compare them to battery tech, there's just nothing. I mean, there's stuff on the horizon. We're getting places. Like, if you think lipos became way more popular in the last 15 years, you could get lipos before that, but they wouldn't necessarily be a high capacity or as safe, frankly. But now, used in everything. Electric cars and model planes and anything that requires recharging.
Yeah, that's lithium polymer for anyone who is wondering what a LiPo is.
Yeah, we need to try and remember our audience may not possibly is au fait with various things. But that's fine because we've already proven we're not au fait with them either.
Yeah, exactly. So I mean, that's there are things on the horizon, you're right, and obviously with all the sort of the carbon batteries that are coming out with that use all like the fancy nanotubes and that
graphene
kind of thing.
batteries.
Graphene batteries, they are essentially the future. I remember watching a video once by Michio Kaku. At that point, he was the head of physics at the University of New York.
Mm-hmm.
He was making a video on how to make a lightsaber in real life, and he was essentially saying that from the size that you could fit inside a lightsaber handle of these nanotubes batteries. It was enough to power an entire city for 3 days.
Oh my word.
So they are extremely energy dense.
Yeah. See, I mean, this is slightly off topic, but it's still interesting. I think also a big issue with batteries, we are finding ways to make them more and more energy dense. It's the discharge rate that we're really starting to struggle with. Because if you're having troubles with getting, sort of making sure they can actually, give out the energy fast enough, that's when you get accidents. That's when you get sort of overheating and battery fires. It's not the only cause of battery fires. If you slam a screwdriver through a LiPo, that'll cause a battery fire. I definitely don't speak from experience. There's one time. So, So anyway, that's why I really like this kind of electric pump feed engine.
Yeah, sounds really cool.
But that was only one reason. The other reason is the fact that most of the engine is 3D printed.
Wow. Okay, that's awesome.
So if you think, 3D printers, 3D printers are almost becoming commonplace now, but for those who don't know, 3D printers are devices that can print, much like, your conventional printer can print 3D objects. So the more common usage is you use plastic. So you have a reel of plastic that you pass through a heated filament head, and you're able to build up a 3D structure by sort of slightly melting the plastic, and you have sort of like these motors that move the head around. So you have X and Y control, and then the sort of the bed that you're printing onto goes up and down. So you have Z control as well. That's XYZ origin, that is.
Yep.
So that's kind of the most common thing for 3D printing. But plastic isn't the only thing that you can print with. I mean, I remember a couple of years ago, in fact, it was when I was looking around universities, I think it was University of Exeter, just so happens, had a 3D printer that printed chocolate.
Wow.
Because all you need is something solid, which, when heated, becomes a fluid.
Yeah.
And that's exactly what chocolate does. The issue they have with chocolate is when you heat it, you get lots of different sort of states of chocolate. I won't go into it now, but it becomes very complicated. It's not as simple as heating it and then passing it through and allowing it to solidify.
Yeah, well, I mean, maybe the different states of chocolate can be for another episode.
Absolutely.
That sounds really cool.
I'll see if I can read up about it and try and find out exactly why a chocolate 3D printer is so hard to build. But yeah, obviously metals. Yep. molten metals is something humans have been doing for centuries, melting metals.
Yeah, of course.
But that's always been, a very kind of labour-intensive process of casting and machining and all of that. So how do you... And you can't, extrude a metal... Well, if you try and put a metal into a 3D printer, you're going to have a bad time. Now, one of the methods, and I have to say, I haven't looked into this enough because Rocket Lab are quite secretive about exactly how they build up their engines, understandably. Yeah. But one of the metals is called 3D laser metal sintering. So what you do is you have a tank full of metal chips. It's metal powder. It's very, very small. I think titanium is used quite a lot, actually. And so what you do is you then apply a laser to the metal powder. That then melts that kind of layer of powder, and so you can create your layout. And then once you've got that, you add a little bit more powder on top, and then you do another run of the laser, and then you do another run of powder and another run of the laser, and again in layers you build up this structure of previously molten metal that is surrounded by this metal powder, which, because the laser hasn't passed over it, hasn't been melted. And so
it's kind of like precision welding.
Yeah, kind of, because it's just powder that you're binding together by melting it and allowing it to reform.
Yeah.
So at the end of it, you then have this large sort of box, essentially, that's just full of titanium powder and the thing, and you just shake it out. You recover the unused titanium powder, and you have your structure that is being 3D printed out of metal. There's a company up in Gloucestershire that was near where I worked that had 3D printed a bike.
Cool.
Sort of, obviously not the tyres, but they had a bike frame that was completely 3D printed and was, strong enough that you could feasibly build it into an actual bike and ride it. And it's a really interesting sort of future for manufacturing, because it allows for much faster prototyping and development. And that's probably why Rocket Lab have gone down this route, because it means they don't have to get all these molds made up and set up contacts with companies. They're just able to 3D print their engines.
Yeah, and I mean, another benefit of that as well is that they're not going to have to change up in the future. They're not going to have to sort of jig around their entire manufacturing process just because it's becoming more viable.
Yeah, exactly. And like if someone goes, oh, actually, it becomes a much better engine if we put on this bit, they don't then have to redesign all of their jigs, all of their equipment, at vast cost themselves. They just change the file in the laser metal sintering equipment to take account of that, and away you go. So it's a really nice method. It does have its drawbacks, but for they've clearly got it down, because, well, I say they've clearly got it down. This is the thing. Rocket Lab, as I said, set up in 2006. Their first launch was in 2017.
Okay.
They have done 2 launches.
So it's taken them a while to get there.
It has. But, they are there, which is a lot better than other companies who, set up and thing.
That's true. They also probably are not in as much debt as some of Elon Musk's companies are.
Quite possibly. I mean, I haven't looked too much into their financials, but, they've launched twice.
Were they successful launches?
One of them was.
Okay.
Their first launch was in May 2017, but they had a glitch in their comms equipment, and it did reach space.
Oh, okay.
But it didn't reach orbit.
Right.
So, or rather, it didn't achieve orbit. So
okay.
I presume it went up and came back down again, somewhere.
It will either have done that or flung off into the abyss.
I'd be a little bit disappointed if it did that, because that's a lot of stuff we've just chucked off into space. The aliens are going to find it.
I mean, space junk is just ridiculous anyway.
It is, isn't it?
Yeah.
So, yeah, I mean, that is... I'm aware I've sort of spoken for a while, but that's Rocket Lab. They're really interesting. Oh, yeah, the cost per launch, they think, is less than $6 million.
Really?
Each launch, yeah. Bear in mind, of course,
cheap.
this is 150 kilos maximum payload, and it's designed for CubeSats. So it's not like the Falcon rockets where you can launch massive satellites, or if you're using the Falcon Heavy, they can't launch a car. But it's a nice starting point, and I'm going to keep an eye on them, because even though I'm not actively involved in the rocket industry, it's really interesting.
Yeah, you see, the rocket industry is something that I may potentially go into in the future. Aeronautical engineering has been a big sort of... I really love aeronautical engineering. But I didn't take the degree at university because I don't know why I didn't, to be honest.
It's funny sometimes. I applied for pure mechanical engineering, and I don't know why I did, because the degree I ended up on was much better.
Yeah.
It's funny why you make some decisions and some, the reasons behind.
I love studying physics. It's very intense, and it's at some points very difficult and makes you want to rip your hair out. But equally, it's very fulfilling.
Yeah. Huh. Well, I think that's probably enough of me chatting about robotics, rocketry. I can't even.
You can't get away from robotics.
I can't get away from robotics. I was going to say I can't chat about rocketry enough because I don't know enough about it, but then I don't know enough about robotics either. So I'm being attacked on 2 fronts.
All right.
Yeah, we probably ought to go to the next section.
Yep. Okay.
Okay, so that was Rocket Lab. Adam, what are you going to be talking about today?
Okay, so I'm going to be talking about ultra-fast electrical current production.
Ooh, I'm already really interested.
So this is extremely interesting. The article that I'm getting all this information from did not go into a huge amount of detail of the physics, but it went into enough detail for me to understand what was kind of going on. It does kind of delve into a bit of the realms of quantum optics, which I'm way over my head, so I'm going to ignore all that stuff and just talk about how the system actually works in
Sounds good.
A simple fashion. Okay, so the overarching idea is that very short timescale laser bursts can be used to shake up the atoms of a very thin piece of glass, which is acting as a wire between 2 pieces of metal.
Okay.
Now,
so first question, how is glass acting as a wire?
Now, this is the thing. It's to do with the fact that the laser burst is on such a small timescale, because it happens at a millionth of a billionth of a second.
Okay.
And essentially what it does is it's got a very large energy density going into a very, very small bit of glass. Like, when I talk about the size of the glass, I mean a size of a few billionths of a meter long.
Can you make a comparison to the human hair?
It is actually. Sorry, 2 seconds.
Yeah, you're gonna have to
I can't find it in my notes.
Oh no! Don't worry,
it's. I think it's a billionth of the width of a human hair. So
wow.
it's essentially a few atoms thick. So maybe 15 to 20 atoms thick.
At that point, does it even classify as glass?
Yes, because the structure.
Oh,
now this is the important bit, because when the laser burst hits the glass, it sort of shakes up the atoms and moves them around and puts them really far away from their equilibrium point.
Mm-hmm.
And it kind of makes it act like a metal. The structure sort of moves more towards a metal for a very short period of time.
Oh, okay. So it almost kind of pushes it into a lattice structure.
Or it's kind of, yeah. So yeah, it's just all about the fact that it's moving the matter at a point very far away from its equilibrium point that actually allows this to work.
Right.
So when the glass structure is all shaken up, it sort of not turns into a metal, but acts like a metal, which causes an electrical current which is induced by the laser to flow through the metal.
Right.
So, yeah, it's a bit confusing, and I think this is where a lot of energy transaction and interaction happens that I don't really know about. This is where it kind of went a bit beyond me.
Okay.
But essentially, the article says that the current can be controlled, and the direction of the magnitude of the current is dependent on the phase of the waveform.
Yeah.
So if you change the shape of the wave, then you can change the direction or the magnitude that the current is going in, etc., etc.
Right. Okay.
So yeah, it also shows that at some level, we can use light in order to tune how matter behaves, which is extremely interesting.
Oh, that's cool.
Yeah.
That's really cool.
Yeah, just a bit of a sort of idea of the history of this theory. It was, and the experimentation. It was first theorized in around 2007 by a postdoc student at the University of Toronto in Canada.
Okay.
And in 2013, researchers at the Max Planck Institute of Quantum Optics were able to actually build one of the circuits, but they couldn't use it to sort of work out the physical dynamics of the system.
Did they give a reason why?
Well, essentially, it was that it's such a small system that trying to extract data from it in any way it's just almost an impossible task.
Right. Okay.
They just couldn't do it because the timescales are so small. The only way that I know of recording timescales in the femtosecond range, which is what it runs at, is by using something called a TDC channel. TDC standing for? I don't know.
One of those acronyms.
Yes, one of those acronyms. But yeah, it was something that I ran into actually at the INFN facility in Frascati in Italy, which is their international nuclear physics laboratories, where they were analyzing data from CERN and the LHC.
Yeah.
And one of the things that they had was a light scintillator, which was used for working out the speed of quantum rays. Quantum rays, sorry, cosmic rays.
Right, okay.
And because of the distance required, or the distance they could get between the two scintillators, they needed a TDC channel to be able to time it at short enough timescales. So that's kind of what we're looking at. We're looking at timescales on and around the speed of light.
Okay. So with my engineer's brain on, so I'm thinking obviously theoretical physics, and then it's all great and good, but how can we practically apply it? If we're talking about very fast currents, are we talking about improving transistors?
Essentially, yes. So the tech is allowing for the development of electrical circuits that will be a few billionths of a meter long, and that can operate in a few millionths of a billionth of a second.
Oh.
So yeah, I mean, this isn't technology that you can build a car from.
No.
But it's technology that can make cars smaller.
Yeah.
Or the electronics in cars, anyway.
Good luck soldering it.
Well, I mean, it uses light, so you don't really have to solder that many components.
No, well, if presumably your inputs and outputs.
Yeah, I mean, I don't know how the circuits would run or how they would be laid out, but I'd imagine it would be more of a three-dimensional thing with mirrors and stuff rather than your normal 2D PCB.
Yeah.
But yeah, because they couldn't actually find out the physical dynamics of the system experimentally, they actually ran a 4-year-long computational simulation.
How long? The simulation took 4 years?
Yes, the simulation.
Were they using an Amstrad computer?
4 years. They were using a supercomputer. And this was actually to develop, and I quote, a very simple picture of the mechanism behind the experimental observations.
Wow, you know it's complicated when it takes 4 years on a supercomputer to get a simple model.
A very simple model, not just a simple model.
Could you imagine if whoever was in charge clicked the wrong thing? Oh no, guys, I clicked advanced. We're going to have to come back in 200 years. It'll be done by then.
Yeah.
It's like, I tell you what it's like. It's like the supercomputer in Hitchhiker's Guide to the Galaxy.
You know, I don't know Hitchhiker's Guide to the Galaxy. Rip into me for it all you like, but I don't know it.
Right, I'll do that after the podcast. But basically, actually, you know what? I don't want to spoil it for those who haven't read the books or seen the movie, but there is a supercomputer which takes billions of years to do a calculation, and you saying that has just made me think we're getting close.
Okay. I'll have to maybe watch the movie. The books will probably take too long. I don't read very often.
Fair enough.
Which is probably why I'm terrible with the English language. But yeah.
But hey, that's it.
Hey, yeah.
So that's really, really cool.
It is. It's very cool.
Yeah.
It's one of those things which at the minute isn't really going to mean much. It's a long way off of being anything in industry, but
the simple fact is, it's an effect that has been found.
Yes, exactly. And I mean, that's what physics is all about. It's all about theorizing things, finding them out, seeing how they work, and then we pass it over to the engineers to apply it in physical systems. And
then we hit it with hammers and complain that it's broken.
Exactly.
That's basically how it works.
Yep.
Brilliant.
Yeah. But I mean, that's it for me for everything about ultra-fast electrical current production.
Yeah, so, I mean, what we talked about, we introduced ourselves.
Yep.
We talked about baby hats and the philosophies of hot dogs, or rather the philosophy of sandwiches.
Yeah.
Very briefly. We're going to have to come back to that one, I think. I spoke about Rocket Lab, which was, the first electric pump-fed engine that was also 3D printed.
Yep, and I spoke about ultra-fast electrical current production in electrical circuits using laser pulses.
I think that is 2 pretty good topics for our first episode.
I think it is. Thank you for joining us on our brief delve into the world of physics and engineering. If you're interested in either of the topics we've discussed, the links will be in the show notes.
Alternatively, if you'd like to contact us for compliment or for complaint, our email address is sparksquarks@gmail.com, and that'll also be in the show notes. That's it from us.
See you next time.
The time travel was H.G. Wells, not Orson Welles.